Okay, Unit 8 is all about conic sections. And the first one we're going to talk about is called the parabola, which you have some experience with. We're going to look at it. You kind of did some extremely simple parabolas you did in Algebra 2 and some Algebra 1. We're going to get a little bit more complex. But first off, what is a conic section? So this whole idea is based off of two cones, two right circular cones meeting at the tip, okay, facing each other. So here's a cone meeting at the tip, and then you have a plane that cuts through them, and what would be the view from that plane? So first off, like, let's go over here. These are the simple things, okay? So let's say if this plane was touching the very edge of the left side of the top cone and the right side of the bottom cone, then that would make a straight line, and that's what you see when you graph linear equations. We could represent them like that. If you had a plane going through just the tip, that would be that'd be a point. If you had a plane coming right down the middle, it'd be like an X shape, so it'd be two intersecting lines. Those are the simple ones. We are not going to talk about those in this section, okay? So we're going to focus on these kinds of what's happening here. So the first one is, let's say this plane, it's not touching the top cone, but it is touching the bottom cone. Or it could be touching the top cone and not the bottom. So it's just one of the cones. It makes a parabola shape, kind of a U shape, okay? So that's one of the conic sections. We're going to spend a couple days on parabolas. And then if it were to cut perfectly, how do I want to say this, parallel to the base of the cone, even though the cone never really stops, that would make a circle. So that's going to be one of them we'll talk about as a circle. Before that, actually, we're talking about an ellipse, which is if it was at an angle, it was cutting through, so it would make like an oval shape whenever it cut through it. That's what, so this is going to be day 1, A and B. This will be day 2, A, and then the circles will be B. And then hyperbolas would be if it cuts through and it hits both of them. So there's going to be two U shapes in one graph. That's a hyperbola. So that would be like day 3. A and B. We're going to talk about that. We're going to focus on those. So ellipses and circles are a lot alike, so we kind of put them together back to back. So let's focus on parabolas. Okay, so sorry for hyperbolas, I didn't write that down. But so there's the four kinds of conic sections we'll talk about. So a parabola, technically to become a parabola, it's a set of all points that are equidistant. So remember back from geometry days, equidistant just means the same distance. So these two things are the same distance from a particular line, which we'll call the directrix, and that's what this line back here is, this directrix, and a particular point, which would be the focus. There's a focus in there. So any point on this line, here's an arbitrary point, the distance here, so the perpendicular distance to the directrix is the same as the distance, the shortest distance, to the focus. Any point in this line is going to be true. If I pick this point right here, there's the perpendicular distance, there's the distance to the focus, they're the same. So all of these points will be congruent. Okay. This is a lot to take in, I think, this chart, but as we start to work with them, it'll hopefully start to make sense, I think. First off, some of the letters like H and K is a vertex. So if I say vertex, that's going to be H, and that's K. Okay, so that's where the H and K comes from. If the vertex is at the origin, then instead of x minus 0 and y minus 0, you just put x squared and y. So you don't need those things. If you look at our first example down here, this, I'm not subtracting anything from x or from y, so it's going to be that the vertex is at the origin. If the x is being squared, it's going to open up or down. That's what you're used to. Okay, so you did a lot of y equals x squared plus 2x minus 3, graphing that in Algebra 2. Those will always open up or open down. If the y is being squared, that's going to open left or right, okay, which means it's not technically a function, but it's still a conic section because I can graph it. So let's see, open up. So the focus, you see a P here. You say, well, okay, so I take HK. I know how to find those. How do I find P? Well, the P is going to be this distance right here. So this distance is P. This distance is also P. So P is how far the directrix is from the vertex and how far the focus is from the vertex. They're the same length. Okay, so that's the P, and we'll talk about how to find that. It's actually up here. Whatever that number, this number is right here, set equal to 4P, and whatever P is, that's how far the directrix and the focus is from the vertex. So that's how far up or down you need to go, or left or right. If it's oriented left and right, you go right and left, and it all depends on which way it's opened. So that's how you find that P. And then the axis of symmetry, well, if the vertex, this vertex right here, if it's an open up, I'll just tip it this way. If it's an open up circle, that vertex, the axis of symmetry goes through it. So if this vertex was at, say, 2, 5, that means I went right 2. Well, the axis of symmetry would be x equals 2. So it's always going to share the h, or that it's going to be x equals whatever the x coordinate is of the focus. If it's open left or right, it's going to be the k, because the k is a y coordinate of focus. So y equals k would be that horizontal line that it would reflect across. The focal length is that P, so we call that the focal length, just how far the focus is from the vertex. It's also the directrix from the vertex, just the opposite direction. And the focal width is right here. If you went this way and this way, that's your focal width. So this is the focal width. Okay, so that's how wide it is at the focus, how wide the parabola is at the focus. So keep those things in mind. If you understand this table, you can make sense of it. It's really not that difficult of a thing. It's very new to us, so at first it will seem weird and difficult, but it's not too bad. So first off, here's my equation, x squared equals 8y, and let's find the vertex. So the vertex. What is being subtracted from x? Nothing. What is being subtracted from y? Nothing. That means this vertex is at the origin. We like those. Those are kind of easier to graph. The focus now, to find the focus and the directrix, I need to find that P. So I'm going to let 8 equal 4P. Because that's in here it says whatever that number is, set equal to 4P, and you can solve for P. So if I divide both sides by 4, P equals 2. So that tells me now, and this guy, it's an x squared, and this is all positive over here. That means it's opening up. Also, this is a positive. If it's positive, you go up to the focus. If this was negative, you go down to the focus. So that'll also help you decide where to go. So if this is a positive 2, means go up 2 units. There's your focus. On the opposite side is the directrix. So directrix means goes 2 the other way. So here's my directrix. It's that line that's equal. So all the points on here are going to be equidistant from the focus and that line. So if I want to find the focus, since it lines up vertically, because this is a vertical parabola, it's going to have the exact same x coordinate. So it's going to be 0. And then I went up 2 units away because P is 2, so that's going to be a 2. Okay. The directrix was my next thing I got to find. The directrix then is going to be, it's not a point, it's a line. In this case, it's a horizontal line, so it's y equals -2 because it's down 2 units. Now the focal width is basically, what's this number? Right here, 8. So the focal width equals 8, which is the same thing as 4 times your p value, which was 2, but I used 8 to find that, so I can just kind of skip ahead. So this 8 means that at this point, at the focus, I go 8 wide, 4 to the right, 4 to the left, 1, 2, 3, 4. There's some points on the line, 1, 2, 3, 4. So my parabola is going through the vertex and those 2 points. Okay, so something like that. Okay, we're not going to, if we want to be more exact, plug in more points. For right now, I just kind of get the general idea of it. Okay, let's flip this over. Unfortunately, you might want to look at the front where I have that table, but see if you understand without it. Okay, so the vertex. Vertex on this. What am I subtracting from x? Well, if it's a +4, that means I must be subtracting -4. Here I got a +1, so that must be a -1. So there's my vertex. The axis of symmetry. Now here the x is being squares. That means it's opened up. It's an open up. Actually, it's going to be an open down. I'm sorry, that's negative. So it's going to be open down wherever. So if I'm opening down, the vertex and the axis symmetry. The axis symmetry goes right through it. So it's going to share the same x coordinate. X equals 4. Now the orientation on this, we can say open down, just because that was a negative over here. It's an x squared, it means up or down, and then the negative means down. The focus on this one, since it's a vertical one, it has to have the same x coordinate as a vertex. Okay, now it's just how far down do I need to go? So I'm at -1, I need to go further. Set that -12 equal to 4p and solve. So if I divide by 4, that's -3. It means I need to go down 3 units from -1 to get to the focus. So that'd be -4. Okay, so there's the focus. And then the directrix, it's going to be since this is an open down, it's going to be a flat line up here. So it's going to be y equals, and instead of going 3 units down, I go 3 units up. So I'm going to take -1 plus 3 and get y equals 2 for my directrix. Okay, so let's use that information and graph it. So -4, -1. X equals -4 is my axis of symmetry, so it's going to mirror itself about that. It is open down. The focus is at -4, -4, 1, 2, 3, 4. So there's my focus. The directrix is up, 1, 2, 3. And if you want to quickly just get a couple more points, we'll look at this -12. That's also the focal width. So here's the vertex, here's the focus. At the focus, I'm 12 wide. So I go right 6, left 6. And that's the general shape of the parabola. Okay. So a lot of these will be a lot wider. Used to, like when we graph parabolas in algebra 2, it's like a U shape. Well, these are like wide U shapes, so a lot of ours are just, they look more exaggerated. Write an equation for a parabola. So let's say the vertex is at the origin, which is 0, 0, and the focus is at 8, 0. If it helps, I would just draw a sketch real quick. So here's my vertex. My focus is over here at 8. So if the focus is over there, that means it's opening up this way. I said open up towards the focus, which tells me, since it's opening to the right, that means the y needs to be squared. Okay, so I'm going to have y, I'll just put this minus something squared equals 4p times x minus something. Okay, so just general. Now plug in the origin, 0, 0. Okay, and then I can see here that the p, this distance is p, so that's 8. That's 8 units. I'm going to plug an 8 in here. So this would simplify to y squared. This is x. I don't need to put parentheses, but I did. And then if I plug an 8 in for p, that's 32. And that ends up being my equation. It meets all the criteria. If you want to use a grapher, if it opens left or right, remember, that's not a function, so your calculator can't really do it all at once. So whenever I want to graph this on the calculator, I have to look at it as 2 separate functions. So what I need to do is I want to solve for y, so I can put it in the calculator. So I think if I have this guy, I'm going to square root both sides. Square with the left side, I get y minus 4. But on the right side, when you square root, there's going to be a positive and a negative root. Whoops. So there's just one big square root there. So the square root is around everything. So plus minus the square root of 8 times x minus 3. And then I bring the 4 over. That'd be 4 plus or minus the square root of 8 times x minus 3. That's actually 2 different answers. So it'd be y equals 4 plus radical 8 times x minus 3. And then, so in y1, but then in y2, you'd want to graph 4 minus radical 8 times x minus 3. So you want to type them in this way, 2 different ways. Okay, and then when you graph, well, let me get the standard window here, window, zoom, 6. So it's going to look like that, and it's going to draw the other half. And there's a little gap there, but it should be smooth. You just graph them separately. So there would be that opening right parabola. And then the last one, prove that this is a parabola. So I've got this in a totally different form. So this is actually this is called standard form for all the conics. We don't really hit that very hard. But standard form for a parabola is written like this, the way those were written. The way we saw it before with x minus something squared or y minus something squared equals a number times the other x or y plus or minus something. So what I want to do is I want to get to that in that form. If the y is being squared, that means it's one of these guys. It's an open left or right one. So separate them. Get all the y's on one side. So y squared plus 2y. I'm going to leave a space equals, and then if I bring that 6 over, it'd be 6x minus 13. Since I want to have it as a binomial squared, I need to complete the square on this. So I think what binomial times itself would yield a 2y? Well, that would be a plus 1. If I did square this out, this would be plus 1, but I just added 1 to that side, so I add 1 to this side, and that's going to equal 6x minus 12. Now, I would like to have a single x here, so just x plus or minus something. So I'm going to divide this by 6. This divides nicely. They don't always divide nicely, but you always do want to divide by this number, this whatever's in front of x, because I want to have a single x inside parentheses, and this would be minus 2. Okay, so there, it's in standard parabola form, so it's a parabola. Now if I were going to find the vertex, so the vertex is going to be -1, +2. If I want to find the focus, it's opening to the right. I'm sorry, I got this backwards here. It should be 2, -1. I put my y first instead of my x first, so be careful on that. I'd like to say I did it on purpose to teach you something, but I didn't. So +2, -1. Now the focus, since this is an opening to the right parabola, so here's a vertex, the focus is going to be to the right, so it's going to have the same y value. It's going to be -1. This is going to be a certain number of units to the right. Well, if 6 equals 4p, that means p equals 3/2. I'm going to take 2 plus 3/2. 2 plus 1.5 would be 3.5. You put 3.5 if you want. And then the directrix, since this is an opening to the right, it's going to be a vertical line. So it's going to be x equals, and it's going to be to the left. So if this was at 2, it's going to be 1.5 units to the left. So that would be 1/2. Directrix would be 1/2. Okay. So just work with those formulas. The p is the important thing. If you can find p, you can find just about anything. So let me know if you have questions.